the annual operation and maintenance for option X is 2 millions, for Y it is 2.5 millions, and for Z it is 3.5 millions. Now all these things, although are given in your problem, you will find that calculating these values is one of the most difficult tasks. Solving the problem is not a big thing, but arriving at these values, that is one of the most difficult tasks. For example, how do you evaluate the recreation benefits that you are getting from a project? It is very difficult to calculate. So you will find that there are many intangible things. For that also you have to assign certain monetary values, which is very difficult thing to do. So once you have got these values with you, solving a problem will not be difficult, but the main difficulty lies in arriving at the values which are given to you in the form of a table. So please understand that it is very difficult to get such values for a given problem situation. Now assume that you have arrived somehow with certain values and then you want to conduct the analysis. So we will go step by step. First, I am interested in calculating the annual cost, C, we are calling that as C, for all the alternatives X, Y and Z. Now remember, whatever we are doing now, this can be done by calculating present worth also. The benefit cost ratio you can calculate by any of the methods that we have solved, that we have studied, either using present worth method, future worth method or annual equivalent method. In this example, I am attempting it with annual cost values. So all the information I will be converting them into an annual value. I will tell you how. For example, for alternative X, at time t is equal to 0, how much you have to invest? 250 million. Now this value I want to convert it into an annual value. How do I do? I will multiply 250 million with the factor A given P at a interest rate of 5% for 50 years. If you just see this particular slide, it will be clear to you. So you have to calculate these values, A given P at a rate of interest of 5% for a given period of 50. So if you calculate or if you refer to the table, you will get a factor value of 0.0548. So if you multiply 250 and 0.0548, you will get a figure of 13.7 million. So what I have done, I have converted this investment value into an annual value. That means 250 million is equivalent to 13.7 million every year for next 50 years at a rate of interest of 5%. So this will be done for all the three cases, X, Y and Z. You will find the values that you will be getting is 13.7 for X, 19.18 for Y and 27.4 for Z. Now operation and maintenance cost, it is given to be 2 million for X, for Y it is 2.5 million and for Z it is 3.5 million. Now once this hydroelectric project is constructed, the government will start getting a revenue of 10 million from alternative X, 12 million from alternative Y and 18 million from alternative Z. So what I will do? This is a negative thing as far as government is concerned. So this particular thing, this particular power sales, we will be subtracting from our total cost. because my cost will come down because I am able to sell the power. So, this is what you have to understand. If you make error in this, your B by C ratio would be also be wrong. So, what would be the total annual cost equivalent for alternative X? It would be 13.7 plus 2 minus 10. Why minus 10? Because 10 million is the money that government will receive once it sells the power. So, the total for X would be 5.7. Just see the last row of the slide, 5.7 million, 9.68 million for Y and 12.9 million for Z. Just try to calculate and cross check these values. Please just once again show the slide. You can just see the bottom row of this. Total annual cost equivalent is coming to be 5.7 million for X, 9.68 million for Y and 12.9 million for Z. So, this is as far as annual cost computation is concerned for all the alternatives. I could have calculated the present cost also for all the alternatives. Now, I will calculate the benefit. If you remember the B by C ratio definition, it was saying that cost to a benefit to the public divided by cost to the government. So, now we are interested in calculating the benefit to the public. So, public is getting benefit in terms of flood control, in terms of irrigation and in terms of recreation. So, corresponding to all these things, you are given the values in your problem. So, 2.5 million flood control value for X, 3.5 for Y, 5 for Z. Annual irrigation benefit 3.5 million for X, 4.5 million for Y, 6 million for Z. Similarly, if you see annual recreation benefit 1 million for X, 2 millions for Y and 3.5 millions for Z. So, you just have to sum it up. So, the total benefit in terms of annual value, you are getting 7 million from project X, 10 million from Y and 14.5 million from Z. Now, we should be in a position to calculate this B by C. So, B by C for alternative X would be, what was the last thing? 5.7 was the cost and benefit is 7. So, 7 divided by 5.7, that would be equal to 1.23. For Y, it is coming to be 1.03. For Z, you are getting a value of 1.12. This you can cross check at your own end, right? So, if you apply the benefit cost criteria and assume that whichever project is giving you a B by C ratio of more than 1 is to be accepted or they are economically viable, all these 3 project alternatives qualify, because for all of them B by C is greater than 1. But we need to choose only one project, right? There are fund constraints, we can't take all the projects together. Let us say our problem is to go for only one project out of these 3. Then we will see how to choose the best one out of it. Now, as I discussed some time back, for such cases you have to use incremental B by C analysis. If you see this particular slide, the annual cost, the initial cost for alternative X is 250. Now, we have found that this 250 million cost is giving me a benefit cost ratio of more than 1. Similarly, for Y, corresponding to 350 million cost, I am getting a B by C ratio of more than 1, and same is the case with Z. Now, what would be my next objective? I will see that whether the difference between y and x, let's say, if I am going for y, how much extra I have to invest? 100 million. 350 million minus 250 million, that means I am investing 100 million extra. So I have to see whether this extra investment of 100 million is giving me a B by C ratio of more than 1. If no, I will be happy with X only, I will reject Y. Suppose I rejected Y, then I have to compare X with Z. In X I am investing 250 million, in Z I am investing 500 million. So what is the extra I am investing? 500 minus 250 million, that is again 250 million. So I have to see whether this additional 250 million in alternative Z is giving me a B by C ratio of more than 1. If yes, I will go for option Z. If no, I will be happy with option X. So this is what we do it in incremental analysis, and that I will show you how it is done. So just see this particular slide. This slide is showing you the incremental analysis. In this, I am finding the B by C ratio of additional investment that I have to make if I choose Y over X. X is costing me in the beginning 250, Y is costing me in the beginning 350 million. So the difference is 100 million. So this 100 million I will try to calculate it in annual terms. Same manner, I will multiply this with A given P, 5% interest rate, 50 years duration. So I am getting annual cost equivalent corresponding to 100 million is 5.48. Similarly, if I compare X with Z, I have to invest 250 million at time t is equal to 0 additionally, and this is equivalent to 13.7 million in terms of annual cost value. What is the benefit you are getting in O&M, operation and maintenance? Your cost is reduced by 0.5, and power sales you are getting a benefit of 2 million extra. So what is your total annual cost equivalent? It will work out to 3.98 in case of first and 7.2 for second alternative, Z minus X. Now on the same manner, in the similar pattern, we will calculate the annual benefit for the incremental part. What is the additional benefit we are getting? If I am choosing Y over X, 1 million in flood control, 1 million in annual irrigation benefit, 1 million in recreation benefit. So I am getting a total benefit of 3 million. So what is the B by C ratio for this additional investment of 100 million? It is giving me 3 by 3.39, 3 by 3.98, which is 0.75. Now this B by C ratio is less than 1. So I will reject Y. That means it is not worth going for alternative Y. That means it is not worth spending $100 million extra. It is not giving me a B by C value of more than 1. So I will reject Y. And then I will compare X with Z. So we have already calculated the cost, and the benefit part is calculated like this. 2.5 million extra I will get benefit in flood control. Again 2.5 million I will get in irrigation benefit, 2.5 in recreation benefits. So total benefit for the additional 250 million is 7.5. So I am getting a B by C ratio of 1.04. Now, since B by C is greater than 1, I will accept Z. So, what is the best option for me out of X, Y and Z? I have got Z as the best alternative, and so I will go for Z. So, this is the process you have to follow when you have more than 2 alternatives for a given situation. So, step 1 is to estimate the cost and benefit. Second step would be to calculate B by C ratio. If you find that B by C ratio is more than 1, you keep that alternative for further analysis. If it is less than 1, reject it there itself. Now, we have to carry out the analysis for those alternatives which are having a B by C ratio of greater than 1, and for them you will have to calculate how much is the B by C coming to be for the additional investment required, and if you get a B by C ratio of greater than 1, you have to keep that alternative, and if it is less, you have to reject it. Like it, you have to proceed and then choose one among a number of alternatives. Now, in addition to this, you will find that there are certain problems that hinder the application of B by C ratio. For example, you will find that identifying benefits and cost is quite confusing. So, once there is confusion, you will find that the B by C ratio is sometimes found to be incorrect, and so your decision based on that B by C ratio would be incorrect. Now, you will find that it is very difficult to identify those intangible benefits in terms of monetary values. For example, how do we calculate the recreational benefit? How do we assess the flood control? How much saving I am getting? It's all these things are very difficult to identify. Now, in this particular slide, you will find that some commonly used benefit cost criteria are given. For example, some people they use minimum investment criteria. So, what would be the decision based on this criteria? The investment which is the of minimum value and with a B by C ratio of greater than 1, they will choose that particular alternative. Suppose there are n number of alternatives, and for them B by C ratio is greater than 1. So, this criteria will tell you to go for that option which has got the minimum investment requirement and a B by C ratio of more than 1. Similarly, in another criteria, they choose that option which gives maximum benefit. So, that is another criteria sometimes used. Then sometimes decisions are taken based on aspiration level. For example, the aspiration level of government would be to control damage of flood at least in 75% of area. So, that aspiration level is 75%. So, based on that they will be selecting or they will be taking the decision. Similarly, in one of the criteria they calculate the maximum advantage of benefits over cost. That means whichever option is having maximum value of B minus C, they will go for that. In some countries they go for highest B by C ratio. They do not see the incremental thing. They will simply go for highest benefit cost ratio. Then in some cases you will find that they go for the largest investment that has a benefit cost ratio greater than 1. This is also sometimes used. Then in one criteria they go for maximum incremental advantage of benefit over cost. That means the alternative would be preferred which has got the maximum delta B minus delta C value. Delta B is the difference in benefit and delta C is the difference in cost. Now, if you take this difference, whichever alternative is giving you the maximum value, you will go for that option. Similarly, in some criteria they go for maximum incremental benefit cost ratio. That means they will go for that ratio alternative corresponding to which you are getting a maximum value of delta B by delta C. And similarly, in one of the criterion, you will find that they go for the largest investment that has an incremental B by C ratio greater than 1. So, these are sometimes used criteria under B by C ratio. So, what basically we find that B by C ratio basically makes you take a particular decision depending on different criteria. So, it is basically helping you in arriving at a decision. Depending on what criteria you use, your decisions could be different, and so you have to be very particular about what criteria you are choosing for your evaluation. Now, we will also see some of the limitations that this particular method has. For example, this we already discussed, the monetary estimation of benefits, particularly intangible ones such as recreation, saving of human lives. These things are very difficult to convert into monetary terms. So, they definitely cause problems. Similarly, the determination of the proper interest rate and time horizon. What interest rate to choose, because the time span for public projects is very large, 50 years, 75 years, 100 years. Now, fixing the interest rate or discount value is quite problematic for such situations, because you may not be sure how the interest rates would fluctuate over such a long period. And then how much time should be considered for evaluation of public projects, that also has some of the problems, right. So, these are some of the limitations that we have for benefit cost ratio. Just to conclude, I will say that there are people who have criticized this benefit cost ratio because of the problems of converting intangible things into monetary values, but still, since there is no other alternative, it continues to be widely used, it continues to be widely practiced, right. However, as far as we are concerned, we consider this as a tool which helps us in arriving at a decision as far as selecting public projects are concerned under a given fund constraint, under a given finance constraint. So, with this I will conclude this lecture and I will take your doubts just after this. Thank you.